Here we want to use the rational zeros theorem as well as our graphing calculator to establish the exact rational zeros for p of x equals 2x cubed plus 11x squared plus 12x minus 9. We notice that the constant term is negative 9 and the leading coefficient is 2. So the possible numerators will all have to be divisors of negative 9, and the possible denominator all divisors of the leading coefficient 2. So making our list of candidates, in the denominator we get just 2 and 1. In the numerator we get 1, 3, and 9. So I'll start using the denominator 2, and I'll get 1 half, 3 halves, and 9 halves. When I use denominator 1, I get 1, 3, and 9. So when positive and negative are taken into account, there are 12 possible rational zeros. When we go to the graphing calculator, we'll be able to use the standard window because our area of interest is between negative 9 and positive 9. So we'll use those for our x min and our x max. I've already entered the function, so I will go to the window to check that I've got the standard window. I'll press graph. And this is the graph I get. And it looks as if I could come down to probably negative 5 to 5. The 9s are not appearing to be zeros. So let's go back to the window and let's do negative 5 to 5 for x min and x max. And now what we're seeing is we're seeing a 0 at approximately negative 3. And that 0 looks like it's probably got multiplicity 2 because the curve is tangent to the graph or to the x-axis at negative 3. And then we've got another value that looks to be between 0 and 1. So it's quite possibly positive a half. Excuse me. Since that is the only number that we have in the list. And so let's confirm this by using synthetic division. I'm going to divide by negative 3. The coefficients are 2. 11, 12, and negative 9. So 2 will be the leading coefficient in the first quotient. 2 times negative 3 is negative 6. Add 11 is 5. 5 times negative 3 is negative 15. Add 12 is negative 3. Negative 3 times negative 3 is 9, giving us a remainder of 0. So we have confirmed that negative 3 is actually a 0. Now, because negative 3 appears to be a 0 of multiplicity 2, I'm going to divide by negative 3 again. Multiplicity of 2, I think I said negative 2. 2 will be the leading coefficient in this next quotient, times negative 3 is negative 6. Add 5 is negative 1, times negative 3 is 3, gives us a remainder of 0. This last factor, the negative 1 is the coefficient of x to the 0, the 2 is the coefficient of x to the first. This last factor represents 2x minus 1, and it equals 0 if and only if x equals 1/2. So we actually confirmed that negative 3 was a 0 twice, and that we also have a 0 of 1/2.